Hello everyone, welcome to Hands-on Physics Video Solution. Today we'll be looking at the Northwest Regional Mock Paper 2, Section 2. Don't forget to like and subscribe. I'm your usual guide, Table.
Right away to the first question, define acceleration. Describe an experiment to find out how the acceleration of an object depends on its mass. Your description should include a diagram, a procedure, a calculation, conclusion, and a precaution. That's B. Define the following, giving one example of each. The C part, a truck pulls on a log of wood with a force of 4,000 Newton. If the log of wood makes an angle of 30 degrees with the ground, calculate the horizontal and vertical component of the force. I3. Given that the coefficient of friction between the log of wood and the ground is 0.6, determine the frictional force on the log. Right away to the solution. A. Define acceleration. This is the rate of change in velocity and its SI unit is meters per second squared, which is the symbol here. Then the next one talks about describing an experiment, which I'm going to omit that. Because I have more videos which will be coming on experiments in physics. So you watch out. The next, I just want to explain a bit about acceleration, how to calculate acceleration. Now, given that the initial velocity of an object is u and the final velocity is v, and this velocity changes from u to v during a time t, then acceleration a is equal to, means you can calculate acceleration by this equation, v final velocity minus initial velocity, all this all over time taken. Take note of this equation. A contact force. This is a force that exists between objects that are touching each other. Examples, we have friction, which is a force that exists between two objects that is sliding on each other. The tension. This is a force that exists on an object that is being stretched or compressed. An example is here. If a man is pulling on a rope, then there exists a force that tries to restore the rope to its initial position, which is called the tension. Then we have the upthrust. Upthrust is an upward force that acts on an object that is immersed in a fluid, usually a liquid. And upthrust will explain why a bucket of water will seems lighter when it is full of water and is under water. Let's take, for example, you want to pull water from a well. Discover that when the bucket of water is underwater, it looks lighter. But immediately the bucket gets out of the water, it becomes heavier. This is because underwater there was an upward force that was helping you to carry the bucket, and this upward force is known as the upthrust. I2, non-contact force. This is a force that exists between objects that are not touching each other, means that the objects are not in physical contact, but there is an attraction or repulsion between them, and this attraction or repulsion is known as a non-contact force. Examples include the weight, magnetic force, and electrostatic force. Here, gravitational force is another name for the weight. Take note. So either we say weight or a gravitational force. Let's move to the C part of the question that talks about a truck pulling a log of wood with a force of 4,000 Newton at an angle of 30 degrees to the ground or to the horizontal. Let's see how the setup looks like. Here we have the log of wood, then the force 4,000 Newton acting at an angle of 30 degrees to the horizontal. The first one asks us to calculate the horizontal component. Immediately you look at this, you will see what? A right angle triangle. Immediately you see a right angle triangle with an enclosed angle and the hypotenuse. Immediately you think about the trigonometry ratios, that is SOHCAHTOA. So the horizontal component, which is the one that acts along the adjacent to our right angle triangle. How do we calculate this? So we are going to look at the trigonometry ratio out of SOHCAHTOA, which one makes use of the adjacent and the hypotenuse. And with this, if we look at this carefully, we discover that the one that makes use of adjacent hypotenuse is cos. So cos x, which is the angle, is equals to adjacent all over hypotenuse. If we make adjacent the subject, that is, we multiply both sides by hypotenuse and here by hypotenuse. Then hypotenuse will cancel here, so we have adjacent is equals to hypotenuse times cos x, which will give us the horizontal component of the force. So if we solve this, we're going to have A, which is the adjacent, is equals to F cos x, where F is a force applied at an angle of 30 degrees, 4,000 Newton. So substituting this in the equation, we are going to have the horizontal component is equal to 4,000 cos 30, and cos 30 is half, so we have 2,000 Newton as horizontal component. Now let's look at the vertical component. We are still going to make use of the trigonometry ratio, SOHCAHTOA. Which one makes use of the hypotenuse, which is a given force? So if we discover that it will be sine, is the sine that's opposite on hypotenuse. So if we make opposite the subject, we are going to have opposite is equals to F sine, and opposite is the vertical component, which is 4,000 sine 30 degrees. If we continue solving this, we are going to have F vertical, which is equals to 3,952.1. Now the next question asks us to state the function of each component of the force. So we are going to look at the functions of the horizontal component and the vertical component. Horizontal means parallel to the ground. So if this box is to move forward, it's going to be due to the horizontal component of the force acting on the box. So it means that the horizontal component pulls the wood so that it moves forward. But if we look at the vertical component, it acts upward, so it's trying to lift the box from the ground, and by so doing, it's going to reduce the force that it is exerting on the ground. Thus, we see that the vertical component tries to lift the wood upward, so that its reaction force reduces, and thus friction. This takes us right away to calculating the frictional force. Frictional force is given by reaction times coefficient of friction. In the question, we have reaction, which is the same as the vertical component of the force, which will multiply that with the friction, which will multiply that with the coefficient of friction 0.6 given in the question here. We are going to have 2,371.26 Newton as our frictional force. The second part of question 7 says define heat and state its SI unit. Describe an experiment to measure the specific heat capacity of a liquid. Your description should include a diagram, a procedure, calculations, conclusion, and precaution. This time again, I'm going to omit the experiment. Like I said, log into my channel, a lot of experiments in there. You can just watch and complete this part of the question. The third part of question D, a 3 kilowatt heater was used to heat 6 kilograms of water for 10 minutes. Calculate the change in temperature. They gave the specific heat capacity of water as 4,200 joules per kilogram per Kelvin. The E part. What is the instrument used in the hospital to measure the temperature of a patient? 2. State the normal body temperature in Kelvin. A column of mercury has a length of 10 centimeters at ice point, 30 centimeters at steam point. If the column of mercury is 14 centimeters long at a certain temperature T, calculate T. The last part, F, here supposed to be F. Briefly explain why I1. A burn from steam is more severe than a burn from equal mass of boiling water. When perfume is sprayed on your hand, it evaporates and your hand feels cold. Right away to the answer, the first one, heat is a form of energy that flows from one point to another due to difference in temperature. And the SI unit is joules. Remember, any form of energy has the unit of joules. Let's go to the third part, since I said the second part is omitted. In the question, we have been given the power as 3 kilowatt, which is the same as 3000 watts. We have the mass as 6 kilogram and the time as 10 seconds and 10 minutes, which convert that to seconds and gives us 600 seconds. Now, from the equation, Q is equals to MC theta theta, where this is quantity of heat absorbed, mass, heat capacity, a specific heat capacity, and temperature change. But then, since we are looking for temperature change, but the heat, since the heat supply is done so by a power supply during a time t, so energy is equal to P power times time. If we substitute that in this equation and make delta theta the subject, we are going to have PT is PT over MC. Substituting the values for power, time, specific capacity, and mass, we are going to have change in temperature is 71 degrees Celsius. Remember this degree Celsius here. The next question asks us to name the instrument used to measure the temperature of a patient at the hospital. And this instrument is a clinical thermometer. Take note, if you omit clinical, you just write thermometer, it's going to be marked wrong because there are thermometers, but the special thermometer used in the hospital to determine the temperature of a patient is called a clinical thermometer. The next one asks us to calculate the body temperature in Kelvin. Normally, the body temperature is 37 degrees Celsius, and to convert to Kelvin, we simply add 273 to the temperature in degrees Celsius, 310 Kelvin. Now, let's move to the next question. We have been given different temperatures here. Here we have the lower fixed point. Here's a lower fixed point, 10 centimeters. Here is our upper fixed point, 30 centimeters, and the temperature, the length of the column at a particular temperature T. So using this data, we have length at the temperature T minus lower fixed point divided by upper fixed point minus lower fixed point, all these times 100 degrees Celsius. Using this equation and substitute the values of the lower and upper fixed point, we are going to have T is equal to 20 degrees Celsius. Let's move on to F part of the question, where we are asked to explain why burn from steam is more severe than the burn from boiling water. This is because steam at 100 degrees contains more heat energy, which was absorbed as latent as it changes from liquid to vapor, while boiling water has absorbed only enough heat to boil, that is, attains 100 degrees Celsius. They say explain why the hand feels cold when perfume is sprayed on it. The hand feels cold because the perfume absorbs latent heat from the portion of the hand where it was sprayed to gain energy to evaporate, thus leaving the hand cold. Right away to question 8, A, B, and C. The first part, what is a machine? A system of 5 pulleys is used to raise a load of 1,200 Newton onto a building by applying an effort of 320 Newton. Define mechanical advantage. Calculate the mechanical advantage of the system. What is the efficiency of the system? Determine the length of the rope which must be pulled in order to raise the load through a vertical height of 1.5 meters. Give 2 reasons why the efficiency of the system is less than 100%. State Hooke's law. Then we are given a table which you have to complete and use it to plot a graph and determine right the way to the solution. A machine is a device on which a small force is applied at one end to overcome a greater force at the other end. In simple words, a machine is a device used to do work easily and conveniently. In other words, a machine is a device used to do work easily and conveniently. In addition, there exist 6 types of simple machine, which include a pulley, wheel and axis, inclined plane, wedge, screw, and a lever. Right away to the B part of the question, which asks us to define mechanical advantage. This is the ratio of the load to the effort. The next one asks us to calculate the mechanical advantage of the system, which is described in B here. We have been given the load and the effort. So we know that mechanical advantage is load over effort. So if we calculate that, we are going to have 1,200 divided by 300, which is 3.75 without the unit. Remember, mechanical advantage has no unit because it is a ratio of 2 forces. Has the load, which is the force, and the effort, which is the force. So this gives a unitless quantity. Efficiency. Mechanical advantage all over velocity ratio times 100. 3.75 gotten here, and 5 here, which is the velocity ratio. I know you'll be asking yourself, where does this 5 comes from? Actually, if we go back to the question here, we were given a system of 5 pulleys. 5 pulleys, it means that the velocity ratio of the system is 5. If you remember what we did in the first section, we had this same question. We simply know that a number of pulleys in a pulley system is equivalent to its velocity ratio. So if we continue solving this question, we are going to have efficiency as 75%. Asked to calculate the distance moved by the effort. Here we are going to use the velocity ratio is equal to distance moved by effort divided by distance moved by the load. The velocity ratio from the system is 5. If we use that idea, we are going to have distance moved by effort is equals to 5 times 1.5, which gives us 7.5 meters as the distance moved by the effort when the load moves by 1.5 meters. The last part of that question B, asking us to give the reasons why the efficiency is always less than 100%. Now, the first reason is that part of the input energy is used to overcome friction between the pulley and the rope. The next reason is that part of the force applied is used to carry part of the machine. This is part, not part. Part of the machine, that is the rope and the lower pulley. So for these 2 reasons, the efficiency of a pulley will always be less than 100%. Move on to the last part of the question C. State Hooke's law. In an experiment to investigate Hooke's law, they obtain the table below. Copy and complete the above table, plot the graph, and write the conclusion from your graph. Hooke's law states that the force applied on an elastic material is directly proportional to the extension, provided the elastic limit is not exceeded. So to complete the table, we simply do a subtraction here, where we are going to take 10, where extension E is equals to the length minus original length. Given length minus original length, it means here the original length L0 is equals to 10. So the first thing we do is we take 10 minus 10, we have 0. We now go to the next extension here. We simply take 11, which is the length, minus the original length, this, we have 1.4. 13 minus this, we have 3. 14.5 minus 10, we have 4.5. 6.5 and 10.5. The next thing we do is we go to our graph and we draw our axis, the vertical and the horizontal axis, and we label the axis. Here we have extension in centimeters, while here we have the load in Newton. Then we look at the values from here, where this one goes from 0 to 35. It means I can go from 0 to 50 here, as 2 centimeters represent 5 units. So I can go 10, 0 to 10, 0 to 10. So I can take 2, 4, 6, 8. Then you put the title of your graph of load against extension. Just doing this, you already have marks without even plotting the point on the graph. Then now let's plot the graph together. The first point we are going to plot is 0, 0, means 0 and 0. So we have a point here, here. The next point we are going to plot is 5 and 1.5, 1.4. So this is 1.4 will be 2 decimal places, we have 0.4. So you have 5 and 1.4, we are somewhere around here. The next point is 10 and 3. So 3 falls here, and here we are 10. So point falls here. The next point is 15 and 4.5, which falls somewhere in the middle here, and 15 we are here. So we have 15 and 4.5. The next point is 20 and 6. So 6 is here. We go up, and here we have 20. So 20 and 6, we plot our point somewhere here. We discover that we have 30 and 9, 25 and 7, 35 and 10. So we obtain the graph we have here, which are points that are classified on a straight line. After plotting our points, we then connect these points with a straight line that runs from 0 here. So our straight line starts from 0 here, straight. Mine may not be straight, so when you're doing that in class, make sure you use a ruler and you draw a straight line. So this gives us our graph of force against extension. We are then asked to conclude from the graph. So the conclusion we can draw from this graph is that it's the material which we're verifying obeys Hooke's law. Right away to the second part of question 8, D, E, and F. D says a young man stands 5 meters in front of a plane mirror. Draw a ray diagram to show an observer in front of the mirror sees the image of the young man. State one characteristics of the image form. How far should he move and in which direction so as to be 3 meters from his image? An object is placed 5 centimeters in front of a convex lens of focal length this. Find the position of the image form. The linear magnification. State the nature of the image form. State Ohm's law. And do some calculations there. The first one, the image is virtual, laterally inverted, and is the same size as the object. Now let's see the ray diagram. We have the boy here, the mirror here, then the image will be formed behind the mirror, the same distance behind the mirror. Then if an observer places an eye here, what he's going to observe is the ray leaving from the boy is going to reflect on the mirror into the eye of the observer. Then the observer will not appear to see the light coming from behind the mirror. So this diagram here shows how an observer here will see the image of somebody standing in front of the mirror. Now behind the mirror we use dotted lines. We use dotted lines because the image formed by mirror are virtual. Then they are virtual. Then since the image is the same size as the object, that's why the man here will see this person in the mirror the same size as the person standing in front of the mirror. How far must the man move so that he should be 3 meters from his image? He should move 3.5 meters towards the mirror so that he will be 1.5 meters from the mirror. Thus, his image will be 3 meters from him. Since we know that the distance from the object to the mirror is the same as the distance from the mirror to the image. It means if the man moves such that he is 1.5 meters here, then his image will be 1.5 meters. Thus, the distance from him and his image will be 3 meters. So, if he was 5 meters, he has to move 3.5 meters, get to closer to the mirror such that the distance left between him and the mirror is now 1.5. Now, they want us to find the position of the image. The image should be formed at this point. This is the object. The image should be formed here. And the position of the image is simply taking u, which is the distance from the object, minus f, which is the focal length. So magnification is 0.5. The f part of the equation says state Ohm's law, then the given experiment, and 1. To plot the graph, what you should first do is make sure you draw your visible axis, the horizontal and vertical axis. You label them PD and current. Now, if you look here, I've multiplied current times 10 to the negative 1 ampere. This is because I don't want to plot 0.00, 0.1. What I did is I converted this to 1 decimal place so that I will now have 0.0, 0.6, 1, 2, 3, 3.8, and 5.0. So, to plot the graph, make sure your pencil is very sharp. The first point is 0, 0. We are here. The next one is 0.5 and 0.6. 0.5 and 0.6. We are somewhere around here. The next one is 0.8. This is 1. Then 0.8 before somewhere here. And 1. This is 1. 0.8 before somewhere around here. And the last one, 4 and 5. 4 on this axis and 5 now. So we have 4 and 5 falling here. Now our points are well aligned, almost forming a straight line. So what we are going to do is just connect the point and form a straight line. So we draw a straight line linking the points. My line may not be very correct here. Make sure when you are drawing in class, you draw a very straight line. Next, they want us to determine the slope of your graph and gives it significance. To determine the slope of our graph, we need a triangle. So we are going to draw a gradient triangle here, which starts from down. Gradient triangle, we have here is change in, here is change in current. Point here, we have the current, which is 5 and 4 and 5. So yes, 4.5, yes, 4.5. And here we have the PD, which is 3.5. So you have 3.5, 4.5. Here we have the current, which is, this is 1, this is 2, so it's 1.5. And we have the PD, which is 1. So we remember that the slope of a graph is always given by y2 minus y1, all this all over x2 minus x1. In this case, our y is PD, so it's going to be change in potential difference all over change in current. So to find the change, we simply take y2, which is 35, minus y1, which is 1 here. So we have slope is equals to 3.5, sorry, not 35, 3.5 minus 1. All this on 4.5 minus 1.5. Lastly, we are asked to determine the physical significance from the slope. We have 8.3 volt per ampere, which is the same as the resistance of the material, which is 8.3 ohm.